Hello, grade 9 students. In this lecture, we're going to revise all the geometric lessons that you have taken in grade 8. First of all, let us remember together what's the meaning of a right triangle. In a right triangle, we have a right angle that forms 90 degrees. The two lines that form the right angle, we call them leg 1, leg 2, or height and base. So this is called the height and this is called the base. And the side facing the 90 degree is called the hypotenuse. So if we have triangle ABC, AB and BC are the bases, and the line AC is called the hypotenuse of the right triangle. So let us start with our first property. And you have to know that this property it's only applied in a right triangle. So the property it's called the median segment theorem. You have to know that in a right triangle, the length of the median issued from the 90 degree to the midpoint of the hypotenuse is always equal half the length of the hypotenuse. So AM, it's the median, it's always equal to the hypotenuse BC over 2, where AM is equal to MB is equal to MC. Okay, so every time the median is going to be half the hypotenuse. Also, we can say that in a triangle ABC, if the median from A to BC, or if this line, which is from A to BC, is equal half BC, then definitely this line is a median, and definitely the triangle is right at A. Okay? Just to tell you that this property actually comes from a rectangle. You know that in a rectangle, the diagonals are equal. So if you just take this part, I'm going to color it. This is a right triangle where this line is called the median and is equal to the hypotenuse over 2 because it's half the diagonal. Okay, so this property came from the rectangle. So now it's called a median segment theorem. The second important property that you have to know, it's called the midpoint theorem. From this theorem, you should know that it's related to midpoints. So if we have a triangle, and also this is applied in all kinds of triangle, it's not necessarily to be right, okay? In the previous property, it's necessary to have a right triangle. This property, no. Any triangle, if you join the midpoints of the two lines, it's always parallel to the third line and equal its half. So the first time we found M, which is the midpoint of AB, then we found N, the midpoint of AC. Joining MN together, you'll find that MN is parallel to BC and equal its half. Okay, so this is very important. So MN is parallel to BC and MN is equal to BC over 2. Also in any triangle, this is the opposite of the property. If we have two lines parallel and one of them is a midpoint, then definitely the other is a midpoint. Okay, so this is called the midpoint theorem. Also, let us apply Pythagoras theorem in a right triangle. In a right triangle, pay attention, this triangle should be right. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the lengths of the other two sides. What I'm trying to say that is the hypotenuse, I'm going to write it just a second. The hypotenuse squared is equal to the first side squared plus the second side squared. This is a property called Pythagoras theorem. So if you look here at this triangle ABC, we have AB3 and AC4 and it's right. So we say that BC squared is equal, which is the hypotenuse, is equal to the first side AB squared plus the second side AC squared. 3 squared plus 4 squared, it's 9 plus 16, which is 25. So BC squared, it's 25. To find BC, we do BC equals radical 25, then BC equals 5. Okay, so in order to find the third missing line in the triangle, in the right triangle, we use Pythagoras Theorem. Now, arcs and angles in a circle. If we have an angle which is inside the circle in this way, as you can see, this is an angle, we say that this angle is an inscribed angle. Why the angle which is the vertex, it's on the center, we call it a central angle, and the angle here, it's directly equal to this arc. So if this arc, for example, is 50, then the angle is also 50, so they are equal each other. While in the inscribed angle, what do I mean by inscribed? It's the vertex is on the circle, the angle is equal half the arc. So if the arc is 60, then the angle is 30. Here we have an internal angle. As you can see, it's an X shape inside the circle. So this angle is equal this arc plus this arc over 2. So the big arc plus the small arc over 2. While if we have external angle where the vertex is outside the circle, then this angle is equal the big. So the external angle is equal the big arc minus the small arc over 2. So a central angle is formed when the two sides of an angle meet at the center of a circle, and each side intersects a point on the circle, dividing it into arcs. And there are 3 types of arcs: minor arc, major arc, and semicircle. As we said, an inscribed angle, its vertex found on the circle, and it's equal half the facing arc. Those are some examples. As you can see in the first example, this is a central angle. Why? Because the vertex is on the center, so it's equal directly the facing arc. This is an inscribed angle because the vertex is on the circle, so 27 here because it's half the arc, which is 54. Any angle facing a diameter, it's 90 degrees. So study this very well. Here we have an interior angle. Here we have this angle is equal half the arc. So the arc is 140, so it's 70. So this angle here is equal to this angle. Why? Because they are facing the same arc. Okay?